It's okay. Thank you. Hello, everyone. I am Sarah Benziane from University of Science and Technology of Iran, which is situated in Algeria. I am here today for presenting you a talk about extraction of TRMM satellite data for rainfall prediction in the 27th International Conference on Circuit Systems, Communications and Computers. So first of all, there's a problem. Yeah. So first of all, let's present the plan. So we'll start with the introduction after state of the art, data set extraction, data set prediction, processing, and conclusion. So to speak about my topic, I have to introduce you four words. Satellites, which collecting the data with satellites is an important process for many applications, including the Earth observation, scientific research, natural resource management, and meteorology. Second word is meteorology. Meteorology is the science that includes atmospheric phenomena and the laws that govern them. Its objective is to understand atmospheric phenomena such as clouds, wind, temperature, humidity, precipitation, etc. The third word is precipitation. Precipitation is an important part of the water cycle and it is essential for the survival of plants and animals. And the last word is prediction. The rainfall prediction is an important research area for the preservation of natural disasters such as floods and droughts. So we have problems. We have to answer questions like what's data satellites, how to extract data from satellites, what are the rainfall prediction techniques, how can we process data satellites, etc., etc., etc. So let's start with state of the art. Talking about the type of data satellites. Precipitation is an important meteorological parameter, but it is difficult to measure. The satellite remains the only instrument which make it possible to provide information from anywhere in the world on precipitation. Several research have dealt with the problem with different learning techniques. Are the data obtained from the instruments that are part of the payload of satellites. They are used for a variety of purposes, including space remote sensing, weather forecasting, environmental monitoring, mapping, navigation, and communication. The data is mainly in the form of image, which are based on passive reflectivity and interactive maps with the attributes of latitudinal and longitudinal coordinates. Some of these attributes are spatial resolution, geometric resolution, temporal resolution, radiometric resolution, and spectral band resolution. Let's talk about the type of data satellites. Data can be defined by both strengths of satellite imagery and GPS data. GPS data is used for navigation and mapping. Satellite imagery, also called space imagery, is a remote sensing technique that uses sensors placed on satellites to capture image of the Earth's surface are as follow: visible images, infrared imaging, water vapor imaging. So the satellite data and the TRMM product. TRMM product is precipitation that's provided by the TRMM research satellite, which was in operation from 1997 to 2015. 615. TRMM data was designed to improve our understanding of the distribution and the precipitation variability in the topics as part of the water cycle in the current climate system. This is an example of the TRMM products. The TRMM product was equipped with several instruments to measure rainfall in the tropical and subtropical region of the Earth. TRMM instruments included the precipitation radar, the TRMM microwave imager, the visible infrared scanner, the lightning imaging sensor, the clouds and Earth's radiant energy systems. Here is the picture of the different instruments of the TRMM. Let's talk about the satellite precipitation estimation methods. There are several satellite precipitation estimation methods. Some of them are combined, spectrals, and micro-ant. We can quote two precipitation estimation using infrared data from the satellite meteosat, analysis of spatio-temporal variation in precipitation by remote sensing, active and passive, precipitation estimation using multispectral information from the meteosat satellite, statistical methods for estimating average rainfall over large spatio-temporal scales using data from the radar of TRMM precipitation, daily hydrological modeling in the Amazon basin using TRMM rainfall estimation, evaluation and adjustment of TRMM precipitation products using artificial intelligence methods. So now let's talk about the data set extraction information. So here the processing of the data extraction are used by, we have choose to use three satellites, TRMM GPM ships from the website NASA. Satellite data mining is an automated process that extracts information from satellite data. Satellite data can be used to extract information such as water level situation, damage observation, time series of satellite images, and displacement fields, etc. How can we extract satellite data? So from the first satellite, TRMM, the tropical, which is tropical terrain for measuring mission, is a joint mission between NASA and the Japan Aerospace Exploration Agency to measure rainfall in tropical and subtropical regions of the Earth. The TRMM was a research satellite in operation 1997 to 2016, designed to improve our understanding of the distribution and variability of precipitation in tropical and subtropical region in the Earth. Was the different steps for downloading TRMM satellite data are as follow. First, we have to access the website of NASA to use here are the different used parameters to extract, and finally, we extract the data as an histogram and CSV format. We used to for our tests the extraction from the GPM satellite. The GPM satellite is the Global Precipitation Measurement, is an international satellite mission that provides worldwide observations of rain and snows. The GPM is the successor of the Tropical Rainfall Measurement Mission (TRMM) and is jointly developed by NASA and Japan Aerospace Exploration Agency. The GPM provides global precipitation measurements with improved accuracy, coverage, and dynamic range to study precipitation characteristics. The GPM also improves the weather and precipitation forecasts through the assimilation of instantaneous shine temperature and retrieval precipitation information. It's the same thing that as the TRMM, we have to access the website to use to extract the used parameters, and finally we get an histogram and CSV format. The third satellite we use is SHIRPS. SHIRPS, the climate hazard means the climate hazard group infrared precipitation with satellite data, is an ensemble of data precipitation more than 30 years. It is a high quality, long-term, high-resolution rainfall data set that is essential to support the drought risk management and food risk security early warning. SHIRPS incorporates 0.05 degrees resolution satellite imagery with in situ station data to create graded precipitation time series for trend analysis and seasonal drought monitoring. Here we have to access to the Climate Hazard Center platform after to extract the used parameters and to obtain finally the data in feed format and net CDF format. Let's talk about now the techniques of precipitation prediction. Rainfall prediction is one of the most difficult and uncertain tasks that have a significant importance on human society. Accurate and timely forecasting can proactively help reduce human and financial losses. This study presents a set of experiments that involves using common machine learning techniques to create models that can predict whether or not it will rain tomorrow based on satellite data. How can we process the satellite data? So there are several precipitation prediction methods. Some of them are the statistical models, numerical weather prediction, the ensemble forecasting, and the Doppler radar. There are several statistical models. Here are some examples: regression analysis, prediction with time series, Bayesian inference, machine learning algorithm, survival analysis. Algorithm of machine learning. We have, sorry, this was in English. We have the machine learning without supervision, the machine learning by reinforcement, and the machine learning by supervision. That's not the right. So finally, we move to the conclusion and say that we have data from satellites. After them, we have to process them with the neural network or specific technique and to get after the the prediction of rainfall, if it will rain tomorrow or not. And thank you very much.
So are there any questions? Much more questions. Did you consider, for example, recognition of topographic objects?
And our work for the, yeah?
Because it is, you said that input data from satellite, you have huge data, so difficult to say what kind of data are important for your task. So let's say topographic objects are very important for some database. You can take some database for topographic images, and for this purpose use satellite. So what about topographic objects?
Yeah, it's a good comment. We don't, even to now, we don't think to use topographic objects. We are using only some numerical data based on weather and the previous rain, and it's a good comment. We'll do it in the future.
And how successful is your prediction?
So we can predict for few hours the rainfall at about 100%, few hours
3 hours
before, but with 100 prediction percent for prediction, and for 90% for days, and 80% for more than 10 days.
What is the period? A few hours before can you predict? One day before, or 2 days? Or so?
No, few hours. It's about 10 until 50 hours.
Okay, thank you very much.
You're welcome.
Okay, so I think now we can close the session. Yes, thank you. Thank you. This is the competition now? Now it's coffee break, yes. Break, yeah. And then
At 10. Okay.